So, hello everyone, thank you for having me here. I would like to present you the tools which we have for automatic data processing and results overview during serial femtosecond crystallography experiments at European XFL. I would like to say that the tools which I am showing here are developed in close collaboration from many people at European XFL, but also in close collaboration with Tom White from DAISY. As many of you know, European XFL is a free electron laser at Hamburg, Germany, and it delivers X-ray pulses at 4.5 MHz repetition rate. They come in trains per second with 2,700 pulses per train, which are split between 3 end stations. It has high brilliance, high spatial beam coherence, and we deliver ultra-short X-ray pulses from a few hundred attoseconds to 100 femtoseconds, and during a typical operation it's between 10 to 25 femtoseconds. Serial femtosecond crystallography experiments are performed at 2 instruments, FEBS FX and FXC. And as you all know much better than me probably, serial femtosecond crystallography at free electron lasers differs a lot from what you have at synchrotrons because we have still images, we have a random orientation of crystals, and it's one shot, one kill, so every shot kills destroys the crystal. And typically, by typically I mean with liquid jet injection, we have a pretty low hit rate, between 1 to 10%. There exist software tools for analyzing this data developed by the community, such as Crystal, which I will be describing more, and dials. Particularities at European XFL are that we have lots of data with this high repetition rate. For example, 5-minute run with Egypt detector provides you with 600,000 frames, and you need to analyze all this data. And another one is that detectors have a modular layout, which is difficult not only to describe the detector in real space, but also in terms of data, because each detector model writes data into separate data files. Crystal is a program suite established for analyzing SFX data, and it allows you to identify break-peak candidates, index diffraction patterns, scale, merge, refine reflections, calculate figures of merit, and much more, as you have already seen by talk from Elke. And the tool which we have developed around Crystal is called XTRAX-Swiss. It's a pipeline tool which abstracts complexity of data at European XFL, utilizes program from Crystal, such as exactly IndexoMagick and Partialator, and automatize parallel processing on our Maxwell cluster. It also handles discrimination of data into pump-on, pump-off patterns during your time-resolved experiments. So you just get scale factors in HKL format as the output. Here is an example of a configuration file which you use for Crystal, and it's just a snapshot of what you need to specify to get parallel processing. You just give your partition or reservation if you have one, and a number of nodes, and your computation will be split on this one. And you also specify which parameters you need to use for peak finding and indexing with Crystal. Another tool which we have developed for the overview of your experiment during your experiment is called DAMNIT, and it's a acronym for Data and Metadata Inspection Interactive Sync. It was developed with the purpose to replace, or at least to help you with taking a log during your experiment. And the aim was to replace spreadsheets which you usually manually enter about information on your sample for each of the data runs and some meta information. It executes a code written in a context file as soon as new data arrives, and provides results overview in a GUI. And recently we have also developed a first prototype of web interface, so you will be able to overview your experiment using your tablet or cell phone. What is the context file? It's a Python code which will be executed as soon as new data arrives, and each function decorated with a variable will introduce a new column to your table, and users are enabled to tailor this context file to the needs of your experiment. It can run simple functions, but also complex data analysis, and heavy computations can be performed on the Maxwell cluster. So for example, here one example shows how to just simply get a number of pulses which you have per train in your run of data. This example shows how to get an overview of your detector averaged over first 25 trains. And since this computation takes a little bit of time, we said that it should be performed on HPC cluster. And as the last example, I show just a small snapshot part of the code which is used to start XTRX-Viz and run Crystal on your data to get the hit rate for your run of data. So, as already mentioned, DEMNIT have been recently integrated with XTRX-Viz, and that's how it looks in your DEMNIT table. We have a couple of columns which are user editable, which are requested geometry. So you just write which geometry file you would like to use, for example, version 7, final 02 or something. And as an input geometry, it will be shown which was used for computation. Same for XViz configuration file. And then you have columns with hit rate, indexing rate, a number of crystals which you got, and some plots such as cell parameter distribution, picogram, and peak count for indexed or non-indexed hit frames. Again, as I already mentioned, the context file is very flexible, so you can extend it and add more features or outputs to it according to your needs. So, large data rate, complexity, and nature of the multimodular detectors at European XFL pose a challenge to our users, and we have developed tools such as XTRX-Viz and DEMNIT to make it easier for you. DEMNIT allows to have an overview of your data during your experiment, and integration with XTRX-Viz allows to do it for serial femtosecond experiments. And in case of questions, please contact us at da@xfl.eu.
Thank you for the overview of your processing pipeline. Does anybody have any questions? Sofia?
Yes, thank you. Really nice. Practical question. So the hit rate and the indexing rate, are they calculated online during the experiment, or is this something that you get at the end after the processing?
So with the current processing, it's done near online. So the calculation starts as soon as your data hits the storage, but it still takes some time. But yep, we allow to split processing on Maxwell cluster. So for example, if you have 40 nodes reserved for your experiment, after 5-minute run, it would take about 10 to 20 minutes to get the final result with everything.